Mesopotamia has contributed a variety of scientific and technological innovations to our time today, some of which are focused on writing, astronomy, mathematics, and more. In order to unravel all of this, let us take you on an adventure into life in Mesopotamia. Mesopotamia is a land situated in between two rivers and is where the first ever city-states were born. City and stylus, linking between the birth of a city along with the invention of writing. In the Mesopotamian civilizations, writing was mainly for bills and accounts, such as records about land bought and sold, quantities of food, animals, slaves exchanged or purchased. However, these writings were not carefully preserved, being used as fillers in building walls in forms of broken pottery and smashed mud bricks. The earliest writing system brought mathematics and the power of planning, organization, and control. People's activities had grown to be very diverse, specialized, that there was a need for ways to keep order and for documentation. These specialized uses of writing had come from society becoming stratified in a complex way, with the presence of landowners and merchants, peasants and slaves, craftsmen and bureaucrats. Just like any civilization, food was key to an early stage city. Farming had to move to a more commercial level enterprise with larger fields and more efficient techniques. One of the said techniques utilized is the ox-pulled plow, which allowed less labor to plant large areas and fewer seeds. With this, planting also took place more rapidly and with improved results as more seeds ended up in optimal positions for germination. Along with farming techniques, an extensive, well-organized system of irrigation was also one of the innovations that made life more efficient for Mesopotamians. Irrigation became a massive, state-sponsored system. It was organized and planned. Hydro engineers created simple networks of canals fed by channels from two rivers, and in turn, these canals greatly extended and systemized as populations grew. Despite having all these efforts for improving farming and irrigation, we shouldn't assume that the farming class of Mesopotamia ate well. Most of the population, particularly the lower classes, subsisted mainly on barley, which was roasted and made into bread, vegetable stews, and some fruits of which they dried, an innovation that allowed nutrient and sugar-rich foods to be stored and carried on trips for military expeditions. Meat was abundant, however, it was only restricted to the upper class. Dairy products were widely eaten and on display during parties given by the wealthy. Mesopotamian integration of mathematics to their everyday lives is also something that we do until now. They used mathematics for documenting economic abundance and exchange, keeping accounts, creating administrative records, and imposing laws, some of which have been developed over time. People in Mesopotamia used tokens to keep track of their goods. Between 3300 and 2900 BC, it evolved to a numbering system, making simple addition and subtraction possible. During 3rd millennium BC, pictographic writing of Sumerians was replaced by cuneiform. Cuneiform is a number system of wedge-like symbols used by Babylonians. The vertical lamp symbol represents the digits 1 to 9 and the sideways wing denotes tens. These are the two basic symbols used in cuneiform. It is a sexagesimal system using base 60 scheme, unlike today's base 10 scheme where place values are powers of 60. In this numbering system, place numbers are separated by spaces starting from left to right. In geometry, Mesopotamians initially used 3 instead of pi, which lacks precision. However, their computations became precise over time. An example that proves this is the YBC 7289 tablet, which shows how they computed for the square root of 2 and the hypotenuse of an isosceles right triangle precisely. This tablet is also an example of one of the many mathematical artifacts they developed and utilized. These artifacts are used for teaching and learning and are evidence of a highly organized society and an urban civilization. Aside from mathematical artifacts, Mesopotamia, often said to be the birthplace of scientific astronomy, produced tablets which contain astronomical details as well, one of which is the Babylonian Venus tablets of the Amisaduqa period, which is said to be the oldest surviving text on planetary astronomy. According to Montgomery and Kumar's chapter on science in Mesopotamia, these tablets document a complete set of observations of Venus rising and setting for more than 21 years, from 1702 to 1681 BC. Another series of tablets is the Mulapin, which was written around 687 BC. These contain a collection of vast astronomical observations that include lists of stars and constellations, solstices, equinoxes, and appearance of Sirius, the brightest star in the night sky. These observations and recordings of the nightly heavens are said to have two main purposes. First, to identify and read omens, which led to the creation of constellations and the zodiac. Second, to produce agricultural calendars and almanacs. These astrological discoveries also created a great influence on culture, not only during the Mesopotamia period, but also some of which still stand until now. According to the assigned text, planets and stars, meteors and comets, supernovae and eclipses were all read as omens of coming events. Eclipses, specifically, were understood to be omens of potential bad times. Venus was associated with the goddess of love and fertility. Furthermore, astrologers were also consulted by kings on a regular basis, whether to go to war and where to locate a new place. This can be mirrored to the modern citizens' use of zodiac sign predictions of his or her daily life, or the reliance for answers as well. With all of the artifacts, tablets, and other archives created during the Mesopotamian era, it was just about trying to have a place to store it in. Alexander the Great came the idea of building a great library in the city of Alexandria after knowing about the great library of King Ashurbanipal that once existed in the city of Nineveh. King Ashurbanipal was a literate and highly learned Neo-Assyrian king who reigned during the twilight height of Assyrian power. Since it was natural for Babylonian scribes to create archives, he decided to build a library not only for archival purposes but also because it seemed to have emerged as a symbol of ruler's power. He sent scribes to search out and, if necessary, copy all important temporary and ancient texts. He also confiscated texts from other collections after military conquest. However, after his death, Nineveh was utterly razed to the ground because of the grudge against Neo-Assyrians, who are known to be cruel and brutal rulers, which caused the destruction of the great library of Ashurbanipal. The said great library was rediscovered in 1849, and all its thousands of tablets were unearthed and excavated in 1850s, but no record or precise list was made of its content. Aside from documenting observations of astronomy and daily life, the Sumerian civilization contributed to the utilization of written contracts. Contracts were part of the social order, but kingdoms and empires demanded laws, rules of behavior, and justice. These contracts were in the form of cylinder seals, which were made from stone or sometimes bone, ceramic, wax, or other material no more than a couple of centimeters high, carved with a bas-relief of images specific to a merchant or commercial partner. It is rolled over a wet clay tablet to leave a signature seal. In addition to contracts, codes such as the Code of Hammurabi, one of the earliest written legal codes, were also present in Mesopotamia. The said Code of Hammurabi is a stele of black diorite on which were inscribed no fewer than 282 laws, portraying a mixture of harsh, calculated, and ethical rules and punishments, eye for an eye laws, and laws on public responsibilities. Babylonian King Hammurabi, who reigned from 1792 to 1750 BC, doesn't just claim authority and righteousness. His rule is determined by the gods and is obedient to the laws and necessities of the cosmos. During his reign, astronomical observations advanced. The rebuilding and enhancing of the city of Babylon as the capital of the new empire also took place. And now, we are at the final destination of our journey in discovering the various contributions of Mesopotamia to modern science and everyday life. Maps. Despite it being vastly technologically advanced now, there are still common aspects that are present in both the modern and the Mesopotamian versions of it. Maps created during Mesopotamia era contain a complex mixture of geographic, topographic, and mythological elements. These are diagrammatic maps wherein relative position is given more importance than scale and distance. Placed in these maps are three domains that represent major portions of the Earth. First, an inner area with a number of symbols which represents the known world, mountains and marshland. Second, a circular belt which symbolizes the ocean, and Babylon being a trading empire, bodies of water were part of their reality. And lastly, an outer area that consisted of 7 or 8 triangles radiating from the circular band. Each triangle represents an area or place, some of which were described as the winged bird ends not his flight, which relates to a region that lies too far across the waters, and where one sees nothing, and the sun is not visible, suggesting the polar regions in winter. In conclusion, maps of ancient Mesopotamia can still be utilized as a basis for creating modern ones, since symbolic representations used in the said era are still applicable to what is used today. Our journey to Mesopotamia has now come to an end. We hope you enjoyed taking a glimpse of life in Mesopotamia through learning about its contributions, not only to science and technology, but also to our culture and daily life.